Hello, everyone, and thank you so much for joining us today for our deep dive into the future of observability. I'm Soini, the Chief of Staff at Hyperflex, and your host for today's webinar. Today, we will be discussing one of the most significant shifts in the data landscape, which is the transition from on prem infrastructure to the cloud. I am joined by Rishabh, our in-house Elasticsearch consultant, who will be walking us through this webinar. If anyone in the audience has any questions, please feel free to write it in the chat box. We will take that up during our dedicated Q&A session. But before we get into it, I'd like to give everyone a brief idea and context about what we do here at Hyperflex. Hyperflex is an Elastic-focused consulting firm that helps organizations turn data into actionable insights through search, observability, and security solutions. Whether you're looking for a migration from legacy systems or managing complex clusters, we ensure your Elastic environment is performing at its peak. Our team consists of over 21 certified engineers, including 16 observability specialists. Also, our team is spread across India and the US to ensure that we are providing a global coverage. At Hyperflex, we have delivered measurable results for the companies that we have worked with, which includes savings of $75 in 6 months and a 57% reduction in operational costs through optimized Elasticsearch upgrades. We also have two products that we have built in-house. The first one is called the Splunk to Elastic migration, which, as the name suggests, helps you migrate automatically from Splunk to Elastic, ensuring that there is a smooth transition. And the second product that we have built in-house is the Elastic Seamless Upgrade, which ensures that you can seamlessly upgrade from one version to the other with just one click. And now I'd love to have Rishabh introduce himself. He would be walking us through this entire webinar. So Rishabh, if you could introduce yourself.
Hello everyone, I'm Rishabh Mahajan. I'm a certified Elastic professional and I work with organizations on Elastic Observability. I help them design, optimize, and modernize their observability practices. I help them migrate to Elastic Cloud.
Thank you so much, Rishabh. Really looking forward to this session. So let's get started. I give the mic to you.
Hello everyone, and thank you for joining. Today, I'm going to talk about how to think about moving observability from on-prem to Elastic Cloud and how to do it in a way that improves the operating model rather than just simply relocating what we had on our on-prem clusters. I also want to set the stage of how I'll approach the session. This webinar is a bit more theoretical, and the reason is simple. There is no single migration framework that can fully cater to the needs of every organization. I mean, every environment is different, every team has different constraints, every organization is catering different apps, different infrastructure. Then there are different risk tolerances, the downtimes a organization can take. Then there are different business priorities as well. So rather than presenting one size fits all migration template, I want to focus this session more on the decision making process that we would have behind a migration, how we can assess the current state, how we can plan intelligently, and how we can control the migration. This will also help us to decide what to move, how to move it, what risks matter the most, and how to avoid turning our cloud into a more expensive version of just what we had on our on-prem. By the end of this session, I expect we can say how we can estimate what we really need in the ECH. How do I decide whether to do a big bang cutover or just do a phased migration one by one, where I run both our clusters in parallel and gradually switch over to the cloud? How do I reduce the risk, and how do I avoid carrying unnecessary cost complexity to the cloud that I already had on-prem? So let's start what matters now, moving observability from on-prem to cloud at scale works. A few years ago, many teams were monitoring a small number of systems, and with more predictable architectures, the traffic patterns were really predictable. We were not seeing much spikes or anything. But now, since we are going cloud native and we are dealing with much more services, more dependencies, we have a lot of APIs in our infrastructure, then we have more microservices, we are going Kubernetes native, we deploy pods on daily basis, we are using more cloud services. We almost all organizations are using either AWS or Azure or some kind of cloud service to have their infrastructure in place. That means that we'll have a lot more telemetry data By telemetry, I mean the matrices, the traces, the logs coming into our cluster. So we see a large amount of logs, matrice, some synthetic monitoring log, everything coming to our clusters all at once. Having so much spikes in this data can really affect how our on-prem clusters would perform. And also, we collect this data across data centers, across all the cloud platforms, across containers, across Kubernetes. This every little thing that we collect is gonna put some pressure on our storage. We ingest the data, how our query performance is working. We can plan the capacity and the upgrades as well. When we are on-prem, we are the only ones who are gonna maintain when our clusters are gonna be upgraded and how much time it would take, how much risk it would be having on our cluster. So keeping that in mind, let's see what modern challenges with our modern observability are. So when we talk about single incident in our observability, it can involve infrastructure, application code, APIs, microservices, third party dependencies, cloud services, and obviously the RUM and user experience signals. At the same time, when we are involving this many things in an incident, we have faster release cycles with AI and everything. Our teams are pushing code really fast. Deadline is very tight. We have unpredictable traffic patterns. We can see spikes anytime. Let's say we have an attack, we'll see this spike in our. That would mean that we are ingesting tons of more logs into a cluster. All the meanwhile, our business expects that we should have good uptime. We don't want our services to go down. Customers expect performance, and for this reason, leadership always forces us that all right, our observability should always be on mark. So with this in mind, the next question comes is the platform that we are using behind the observability, is it keeping up with the job that we are asking it to do? So this leads us to what are the limits on our on-prem observability. So when we talk about the on-prem constraints, the first issue would be definitely the capacity planning. When we are having our clusters, Elastic cluster deployed on-prem, this forces me to predict that how much telemetry will grow. I need to have this known beforehand so I can accordingly plan my cluster sizing. I need to know how much compute I would need. I don't want my query performance to go down once I'm already have my cluster in production and everything is working. I need to know as well that how much hardware I would need more if in scenario where my cluster is not performing well. And I also need to know that how can I procure that hardware beforehand? I would have to reach out to multiple teams, maybe the infrastructure team, maybe the networking team, to have this additional servers to my cluster added. Then comes the second issue that we have. We have very limited elasticity when we have some spikes on our on-prem clusters. We don't have any mechanism of auto scaling on on-prem servers. So we can't really predict what we can when we have traffic surges, when there are some incidents, or maybe a new service launch with unpredictable traffic pattern, how well our cluster would perform and how elastic it could be. The third is operational burden. Obviously, when we are doing anything on-prem, we are the ones managing it. We manage infrastructure, we manage the cost, we manage the storage, we manage resilience. We have to manage the upgrades as soon as the new versions of Elastics are released. They come in with tons of new features. So we definitely want to have upgrade to take advantages of all of them. We need to take care of the server patching. And for that, we would need someone from, let's say, if we are using Linux servers, so we need sysadmins as well. Then the next issue is expansion. So when we are on-prem and say, let's say a new team is formed and they come to us, okay, we have a couple of services and now we want to use your platform to have our observability enabled. But we need more planning for that beforehand because we can't just scale the cluster as is in our on-prem environments. We need to have a plan of how much data we'll be ingesting, how much deployment effort it would be to actually scale the cluster, how much coordination between the team do we need. And then the final thing is the alignment with the current infrastructures that we have. We are going more cloud native. We use AWS, we use Azure. And if the environment I'm monitoring is going to be more cloud native, more distributed and hybrid, then why to keep my on-prem observability model, which can be less aligned to what systems are supposed to be nowadays? So let's see why should we should move to the Elastic Cloud. So when I say we move to the Elastic Cloud, from technical perspective, what cloud gives me is it's more dynamic scaling. I can just go onto the Elastic Cloud and say, okay, I just need 4 more terabytes of storage, and it will allow me to have it in my cluster. I don't need to run over to the infrastructure guys. Okay, give me some servers, give me some disk, because my cluster is not performing well right now, having a bottleneck. It provides me with improved resilience as well. Most of the tasks that can hinder our clusters, like some patch management, if there is some bugs in the underlying servers, we don't need to take care of that in the cloud. Elastic will do regular patching for us. We'll see that our cluster will go regularly into the maintenance mode. We'll have no downtime, but Elastic will take care of the rolling upgrades and everything to bring up the cluster with the most recent security patches. Next would be better alignment with hybrid and cloud native environments. When I talk about the Elastic Cloud, since it is already running in AWS and Azure, it is very much aligned with what we have in AWS Cloud, the applications. We have options of routing to our clusters directly from the AWS VPCs. So we don't need to use some kind of over the internet routing. So that way it becomes a bit, not just a bit, a much more cloud native approach. With this, we saw that how modernizing observability operation is really easy with Elastic Cloud. Let's quickly get ourselves familiarized with what a deployment management in cloud looks like. So we can just quickly jump on to elastic.cloud.co. I already have it open. So this is what Elastic as a managed service page looks like. We can come here, we can say that I want to have Elastic hosted deployment created, and with just a bunch of clicks, I can just name that, okay, this is my webinar cluster. I want it to be on Google Cloud. I want it to be on AWS or maybe on Azure. I can select what version I need and the hardware profile as well. And it will just give me bit of summary of what my cluster looks like, the pricing. I can tap on create hosted deployment, and it will spin me up a production ready cluster in just 5 minutes. And that's a great thing to have. Now, until it is getting launched, I just want to clarify what I actually mean when we move our Elastic on-prem to Elastic Cloud. When we move from Elastic on-prem to Elastic Cloud, all of our same core observability workflows will remain similar. We'll still work with logs, we'll work with matrices, work with traces. They are going to be exactly similar. But what changes here is how we would be managing our deployments, how capacity is adjusted, how lifecycle tasks are handled, and how much operational burden sits on our actual operations team. All right. Since it is still launching, I have another deployment ready where I can show you how scaling and downsizing works. So this is what a typical cloud deployment page would look like. We have a bunch of options on the left hand side. We can check our health. We can check the logs and matrices from our actual cluster. We can check for the performance, the activity that is happening with our cluster, then a bunch of more information. And here we have option to edit. If we want to scale our cluster, we can just quickly go here and say, okay, right now we had two zone 45 GB storage. That means we had 90 GB of storage in our cloud. Now the day comes that I want more storage I just want to double my cluster. So what I'll do is I'll just click on the new sizing per zone, and I can just go below here, tap on update, and Elastic will manage rolling upgrades, rolling changes for me. It will add more nodes to my cluster. It will take care of the snapshotting as well. It will take a snapshot so we don't lose any data. So it is really simple. If we were all on-prem, we would have needed, if not months, at least weeks of planning to do all of this to increase our cluster size. Similarly, in case of upgrades as well, we can just go to a deployment, and here we have like deployment version 9.3.4. If you wanted to upgrade this, we can just quickly have, there would have been an arrow here. Since it is being created, it is not shown yet. But once we tap on that, we'll get the options to which version we want our deployment to get upgraded to. And similarly to the previous case, it will just start a bunch of activities here. And once it is done, it will show us, okay, our cluster is now upgraded and we don't have to do anything. It's all going to be automatic. All right, let's jump on to, so we have already seen what deployment management in cloud looks like. All of our workload flows remain similar. We still work with the same data. We have same dashboards. We have same alerts running. So nothing changes. It's all about how our deployment management becomes more flexible, how flexible we can be to upgrade new sources, how we can help our teams and everyone to be more streamlined towards the cloud native approaches and how they can absorb their applications well enough. So, with this, let's move on to our actual topic, that is what a successful migration should deliver. When we talk about a successful migration, we don't want to have any loss of critical visibility. By that, we mean we don't want to miss any alerts or anything that we would have while we are migrating from on prem to cloud. We want minimal disruptions to our teams. We don't want our users to just wait for our upgrades to complete or even the migration to complete before looking for their obsolete data. We want our ingest and query performances to perform as is or even better than what we have on cloud. We want exactly similar governance and access control that we had on our on-prem clusters. We don't want our cloud clusters to have even a little bit less governance or anything. Even Elastic now provides government cloud to deploy their cluster where there is really strong governance required in the organizations. Then we also want to have cost aware data management. We just don't want to put everything that we have in our on-prem system to the cloud and bulk it up. So it costs us a ton of money. We don't want our stale data to be on cloud. And we also want to have a foundation for the future growth. Since we are on cloud, our teams could really work on what could be better and what new functionalities could be used. That's really easy when we are on cloud. We can upgrade to newer versions and just help our team to try out new features as well. All right. With this, I'll quickly jump on to the common migration models that I have seen working across different organizations. So, first one is the lift and shift. In this particular model, what we do is we usually just take whatever we had on our on prem and move over to the Elastic Cloud. Why we do this? Because it is really a simple pattern. We don't want a lot of refactoring or changes to what we already had on on-prem. Maybe our teams really had best of what we could have from Elastic on our on-prem, so we don't want to change much, and we want this thing to quickly happen, the migration thing. So what we do is we just change the endpoints from the Elastic Cloud to the Elastic Cloud and move everything that we had on our on-prem to cloud. So these are good for like really small organizations where there we don't have much data in our clusters. So it would be really quick to get over with. And then we can see about, I'll talk about the next one, that's replatform. Replatform keeps the core structure, but modernizes selected parts. By that, what I mean is, for example, a customer wants to move Elastic Cloud, but also improve the operations during the migration. So they decide to keep the obsolete architecture. They just want to replace some of the log stash heavy pipelines with maybe Elastic agents or Filebeat, which are lighter. Then they want to update the retention of the ILM that they are using, how they keep their data in a hot, cold, or frozen architecture, because that is gonna affect their cost eventually in the cloud because they would be paying for what they store. They want to simplify the data routing and like standardizing the onboarding process. So they they don't want to have some log stash or anything in between. If they want to remove them completely, they can directly move over to Elastic Agents and say, okay, now I'll be using Elastic Agent and send all my data directly to my Elastic Cloud cluster. So in practice, what this scenario would look like is our existing use cases, logs, metrics, and security data will be as is. Our core architecture, how we model the data and everything, would remain the same. Some of the components that we talked about, like Logstash, maybe from Beats we move over to Elastic Agent, they would change. We will change how our data is retained. So does this kind of models fit good is when the customer wants a balance between speed, but they also want the improvement to be taken into consideration. They don't want to have full redesign, but they want to have some cloud native components that are easy to manage on cloud. So that's where we take replatform into consideration. The next is redesign. When I talk about redesign, here we take the chance of migration to rethink the entire architecture more fundamentally. Let's say a client has so many oversized clusters. We have very noisy multi-tenant workloads that generated tons of logs and matrices. We have very inconsistent ingestion patterns. Sometimes we are seeing a couple of TBs in a day. Sometimes we are just seeing some GBs. In that case, what we think about is to redesign the actual architecture, what could be done to have more optimized version of what we have on our on-prem. So how do we redesign? Maybe we split the workloads by use cases or by business domains. On-prem, when we take a license, usually take a license for just one cluster, but it's not the case on the ECH. The licenses on the ECH are organization level. So we can maybe have like a security cluster, and then we can have an observability cluster, and it would all be covered under the same license. We can create multiple deployments there. So it's much cleaner to have everything in place and properly architectured. This is kind of a good fit where our environment is already too much strain, and we want a long-term optimizations both in terms of operations as well as cost. The last one is one of my favorite, that's hybrid coexistence, because it allows us to have really zero downtime migrations. We keep both the clusters together. We run on-prem as well as the cloud. And but in a chunk by chunk scenario, we move our on-prem workloads to the cloud. In this way, it is already battle tested thing. We can test as many times we want, for as many time. We can do the validations, and it gives us a lot of flexibility where, and if anything goes wrong, we can just quickly switch over to on-prem and use it. If not, our hybrid will still be in place. We can do things like CCS, CCR to help our customers use both of the clusters at the same time and without any downtime. So now we have the models that we use. Then there comes some of the approaches that we can do. Now we have one thing called Big Bang migration that usually goes hand in hand with the lift and shift, where we move everything at once. We do a single cutover and move everything towards the cloud. What I like about this is it is really simple and short process. What I worry is it is more pressure on the cutover event. What if something goes south? What do we do? We would have to do exactly the same process in reverse to move everything back to the on-prem. And for that brief moment of time, we will have a downtime. We will risk our data as well. Then the second one is stage migration. What we do here is we categorize our environment by use cases, by environments, or maybe by team. So what we do is, since our environment is larger and multiple teams are involved, so we need our risk to be reduced. So what we do is we, let's say, have some teams that cater to app one, some teams cater to app two, and we have like 15 apps. So we'll just take the apps that are the lowest priority and then help them migrate. Once they are in place, we should be good to go with the higher priority apps. That way we go ahead with stages. The last one is clean and migrate. Here, this takes place when we know that I have a lot of data on-prem and I have room for optimization. I don't want my stale data to be the part of the cloud. So what I'll do, I'd go ahead and review the retention. I'll try to simplify my architecture. I'll see what workloads are really not important and could be avoided. So I can finally migrate a cleaner footprint rather than bulking up my cloud deployments. So what I like about this is this migrates a lower volume to a cloud. That would mean that we would have low cost. This has a pretty much cleaner architecture because since we already removed all the unnecessary chunk that we had that was sending data to our on-prem infrastructure. And for a long term, it's much better because whenever it comes to the cost, it's always to keep it low. So now we know what the models and the approaches are. We can quickly jump to what a single migration would look like. It would have some phases, how we plan it. So first thing first, even if we are doing the testing, what we do is we assess what we have on our plate right now. We assess what version a customer is on right now. Is it on like say a 7.10 or 7.15? And decide if it is even possible to move to Elastic Cloud with that version, or do we need to have some upgrades in place before we can actually move our clusters to Elastic Cloud? We need to take care of how many clusters are involved in our migration process. Is it just one? Is it just two? Or maybe we have like tens or 20 of cluster, and do we need to create plan for them as well? We need to take care of how many nodes we have, what kind of nodes we are using. We need to list them down as well. Are we using hot, cold, frozen, or we are just using hot and cold right now? And do we want to change them in cloud as well? We need to see what retention we would have in cloud to have estimation of what storage we would need. We need to have the integrations that we are using on-prem, and are they supported in cloud as well? If yes, how are we going to implement them? We need to check for the security requirements as well. If we need some IP filtering to our cloud cluster, if we need some restricted accesses, we need some RBAC. Most of these things are the RBAC and users are restorable, but we need to take care of the routing and everything that is to the cluster manually. And we have that option available in cloud as well. And the last thing is what pain points we are trying to solve. It is always important to know what actually what's wrong with our on-prem cluster or not optimized, and then take it into consideration when we move as well. Once I have the assessment phase and I have list of things on my book, what I do next is I'll plan and I'll define what my migration would look like. I will have my target ECS cluster defined. I'll have my sizing assumptions. We'll see how size assumptions later in this session as well. I'll analyze what my security requirements were and how could I design them. Then I'll check for what my validation plan would look like, what my migration plan would look like. If something goes south, what will be my rollback strategy? Would I have any downtime in case of rollbacks? Or can I do a zero downtime migration as well as rollback for my customer? Once I define all of this, I'll go ahead and start migrating. I'll migrate a really low priority workload first, maybe in a testing or development environment. And if everything goes good, I'll go ahead and migrate more workloads. I'll validate them. And after this, I'll expand it to all the workloads that I would have in the cluster. And it's not over yet. Even though we are migrated to cloud, we still have a tons of work to do in optimizations. Elastic is introducing new architectures every day. If I take example, we have some really good frozen nodes available now in Elastic that are really powerful for search performance, but at the same time, they are really like 50x cheap than hot nodes that we have. So that way, I'll always try to optimize what we have in the cluster, how I can change my infrastructure for being more cost beneficial as well as more performant. And this is all going to be really easy on cloud, since we saw that how easy it is to scale, add a node or to remove a node from the cluster. So this brings me to just quickly summarize what the key architecture components are that we should be taking care of and think about in layers. First and foremost will be our data sources. So my applications, infrastructure, cloud services, Kubernetes, maybe containers. I need to know beforehand what are the apps that I'll be dealing with and how I can move them. Then next comes the collection layer, the agents, the log stash, the pipelines. I need to take care if my on-prem is already optimized, I am using the best practices, like I'm using the Elastic agent or not. If I'm still using some file beat or metric beats, so how I can integrate the change from metric beat or file beat to Elastic agents in my migration plan. Next would be the routing layer. It's one of the most fundamental layers that runs into the issues. Let's say if I'm working as a MSP, a managed service provider, in that scenario, most of the times, the sender of the data is not going to be in my organization. They would be sending data from some remote organization, and I need to take care of the data being arriving at my cloud deployment like it did on my on-prem. So I need to take care of filtering, the forwarding, the enrichment of the data in between. So routing is one of the layers that we should be really careful about. I need to take care of the dashboards, LAT, workflows, whatever shared objects we have, even though they don't change, but it's always good to have validation on them, as sometimes when we upgrade or migrate, some alerts could go deactivated. So make sure to have validation in place for dashboards and alerting as well. Next thing is we should always take care about security and access controls. We need our RBACs, our roles, our users always be in place before we even migrate to the cloud so that we don't have some unrestricted access to our some of our users that can potentially harm our regulations. With this, we can quickly run through what we should validate. So always validate data completeness. There isn't some inherent inbuilt tool that we can do, but we can write some Python scripts. We can check the counts of dogs on our indices that we had on our on-prem and whatever we stored on our on-cloud. We should take care of the parse enrichment accuracy. Let's say we moved over from FileBeat or Elastic Agent to more native integrations. They are out of the box. So let's make sure that they are parsing what exactly similar to what we not. They are maybe they are using some have a benchmarking in place. If you don't have a benchmarking tool in organization, there are tools like ESRally that could be used to benchmark the query performance. Use them. And the last thing would be user access permissions. We definitely don't want to have unrestricted access to any of the user that could harm our regulations as well. So make sure to have the RBAC in place before migrating anything. With this, let's get our hands a little dirty. Let's see how we plan the calculations to migrate. So it consists of four parts. First would be how do we estimate the storage? How do we reduce the scope of my migration? How much data I would migrate? Next is going to be my downtime exposure and then my transfer window. So let's say we, for example, have an 800 GB per day of ingestion and we want our data to be have to be retained for 30 days. And we have regulatory measure that, okay, I want to have at least one replica of my shards so then I don't lose any data. That's obviously the best practice. Along with this, I'll always have a growth buffer just to make sure if even in the event that I'm not expecting, my cluster performs well. I don't go berserk over the storage and my cluster goes down, something like that. I'll just calculate that, okay, from at 800 GBs a day for 30 days of retention, since I'll have a primary and replica, so we'll multiply it by 2 and a bit of buffer. So I'll have 57.6 TB. So this is the data that I'm expecting in cloud. But always make sure to have this only as a 85% of my cloud storage because the designed to ingest. And once it reaches 95, 96, even our query performance ingestions will be affected very percent. And once it goes beyond that, sometimes Elasticsearch will even stop ingesting the data. That would mean there would be loss of our data, and we don't want that to happen. So always have it below 85%, whatever we calculate. Next is the migration scope reduction. Let's say if I have 60 TB of data, do I really need to move 60 TB? If I have 15 TB of stale data, I just don't want it in my cloud cluster. It's going to cost me a lot. So I'll just remove that 15 TB and not move it to cloud. That would mean I saved my one-fourth of my cost. Then if we have some archivable data, so why not to archive? Why not to use the frozen nodes? They are really cheap compared to hot, cold, or even warm. So by this way, I can reduce how much data I want to migrate to cloud. Next would be the transfer window. This is the time that I would take to move my legacy data to the cloud, maybe using snapshot or restore, or maybe reindexing. Let's say if I have 20 TB of data to move, and effective throughput of cloud is around 250 to 350 MB per second for restoring. That would mean that I would need 22 hours just to move my legacy data to cloud. And if I'm planning to have a downtime of 4 hours, I immediately know that this is not going to work. I would have to move this even before the cutover, even before my downtime window. I want all of my data to be moved to the cloud. Then next is the downtime exposure. This is basically the time that I would take for cutover validation and rollback if required. And this is critical for the business perspective, where we need to ask the businesses if it's okay to have 4 hours of downtime window, or do we need to have our strategy reformalized so that we can have some kind of hybrid so we don't have downtime, that kind of stuff. Let's say we walk through a work example. So I have a 12 TB node on-prem deployment with 45 TB of stored data. I have 400 GB of new ingest every day with 30-day retention, some couple of integrations, and I'm planning for a 4-hour downtime window with my business critical dashboards and alerts in place. So first thing I would challenge is obviously the storage. Do I need 45 TB? If not, let's say 5 TBs is still. So I'll only focus on moving that 40 TBs. That would change my migration profile. Second, I would estimate my target storage. If I am expecting 400 GB a day for 30 days, and I'll have a primary replica with a bit of growth buffer, I get 28 TB. And then on top of 28 TB, I can even break it down. Let's say I just want 7 days to be in hot, and then my data is not frequently searched, so I can move it to cold. So what I'll do is I'll just in my ECS cluster have an architecture in a way that I'll just have 10 TB of hot storage and then rest for the cold nodes. That way I'll save some of my cost and also have my data in cloud. Next is the transfer time that we would need. So since we need to move 40 TB of legacy data now, and effective throughput of cloud for restoring is just 300 MB per second. That says 37 hours. So that's not gonna fit my 4-hour downtime window. So what I'll do is even before I plan the actual migration, I'll calculate this timing and I'll initiate this with a bit of buffer time. Let's say if I'm migrating today, I'll have this migration take place even day before today. So I don't have to wait when I actually have the cutover window. So this is how I would approach it. I'll move the bulk data ahead of time. Then I'll use downtime window for just final sync where we move the most recent data that I would have in my cluster, and then do a bit of validation if everything is working as well, because legacy data is already moved. That should be it. That in this way, I would reduce pressure on most sensitive part, that is our cutover, by having legacy data already being ingested. And since we already had the data in cluster, we could have easily done the validation of dashboards, alerts by simulating them. So in this way, we can approach the migrations. We can have different patterns, different models to be used, maybe together, maybe as a single ones. But most of the migrations that I have done are basically the phase migrations. They are the best ones because they allow us proper to validate everything before we run into some big issues or anything. So that should be it for this session.
Technical ground today. So now we will move to our Q&A section. And if anyone has any questions, please feel free to put it in the chat box. Rishabh can help us answer. And we do have one question which says, does it support blue-green deployment by default?
Yes, they are all going to be a rolling deployments. Even if when we do the upgrades in Elasticsearch, they are going to be rolling upgrades. So our clusters is never going to be down in cloud. They'll always do it one by one per node. We do have options for doing all at once, but that would have downtimes. But the default one is to have blue-green type deployments.
Okay, that's good to know. I do have a question for you, Rishabh. So my question is, which day-to-day responsibilities disappear once infrastructure management moves to the cloud?
Actually, that's a very good question, and that's the gist of moving from on-prem to cloud. Let's say I'm using my on-prem environment to set up my cluster. As soon as I go on-prem, I have to maintain the hardware, the VMs, the servers that I'll be deploying my cluster on. Even when I have the cluster, I mean the servers in place, now my responsibility is to actually deploy and install an Elastic cluster on them that is production ready as well. That is gonna take some time for newer teams as well. If they are not experienced, maybe they would require some external support for that. And let's say even if I deploy the cluster, I still am the one to manage that as well. What if one of my server fails? I would be responsible for patching it. I would be responsible for upgrading my cluster to newer versions. I would be responsible for any additional infrastructure like fleet server, one of the components that is required to run Elastic agents in a managed way. But as soon as I move to cloud, Elastic will manage it for me. It will give all the flexibility to me to just ask them to add or remove a node. If something goes wrong, Elastic would be the one patching it. Elastic would be the one restarting the nodes if they go down. So it's really easy operationally to have Elastic in cloud and let our teams focus more on how we can get more out of the Elastic cluster in terms of observability, security, or maybe even such. So we give room to our teams to be more, uh, a kind of a more playground for them to be really imaginative and play with Elasticsearch.
Okay, thank you. And one more question from me. What risks do team underestimate when choosing a big bang migration?
So when we talk about Big Bang migration, it seems really simple, one-to-one cutover. We just in a single second we just maybe route DNS directly towards the cloud. But there are inherently a lot of risks when we do a Big Bang migration. Now, if we talk about the risk, let's say, what if we have a cutover disruption? If the dependencies I had with my on-prem are not correctly mapped to my cloud cluster, what if routing fails? What if even my data centers can't even reach the Elastic Cloud deployment somehow? Maybe some traffic filtering dropped the traffic in between. What if my pipelines that we had on the on-prem can't actually work with the cloud endpoints? What if they are in an isolated environment? They are running in their own VPCs. And obviously, then there could be some kind of configuration drifts in dashboards, in alerts as well. I have personally seen that when we do upgrades or migrates from on-prem to cloud, sometimes the alerts that we have get deactivated. So we have to go there and manually activate them again. Then there could be some changes to dashboard as well. So let's say I moved from Filebeat where we did all the parsing manually to an Elastic agent that uses some integrations out of the box and they use ECS backed fields. So there would be some changes in the mappings for indices that we had on prem and on what we will have on cloud. And in that scenario, our dashboard will get broken because they won't be able to find the fields they are built on top of. On top of all of this, the configuration changes, the graphics and everything, we still have complexity with the rollbacks. Let's say if I just do single big bang migration to cloud, I move all my traffic to cloud. What if any of the thing goes south? I would need immediately to move back to my on-prem. But now, since I don't have anything like hybrid, I'm not running two clusters in parallel where I can quickly switch the traffic or use the on-prem cluster. In that case, I would have to entirely do the migration process backwards by moving from Elastic hosted to on-prem, and that would mean lot of downtime to our environment. So that's some of the downsides I see with the Big Bang migration, and I personally don't like. That's why.
Okay, thank you for answering that. We have one more question, which is when upgrading Elasticsearch, does all indexing can be copied automatically or do we need to rebuild it? How do you estimate shardings for a given cluster? Like, what is base formula? Can you please talk a little bit more about this?
So your voice broke for me. Can you please come again with the starting part for the question?
Hi, can you hear me now?
Yeah, I can.
Yes. So when upgrading Elasticsearch, does all indexing can be copied automatically or do we need to rebuild it? How do you estimate shardings for a given cluster? Like what is base formula? Can you please talk a little bit more about this? It's
Sure.
somebody has asked us in the chat box.
All right. So when we talk about upgrading the clusters, all the shards, mappings, and everything remain exactly as is if we are doing a single major upgrade. Let's say if we move from Elastic 7 to Elastic 8, there would be no change at all. We won't even need to have reindex or anything for our indices. That is due to the leucine compatibility that we have between a single major upgrade. So in terms of upgrade, we don't have to worry about changing to index mappings, index settings, or anything. But when we do two major upgrades simultaneously, let's say we were on Elasticsearch 7 and we wanted to go to Elasticsearch 9, In that scenario, Elastic would ask us that, okay, I can go till Elastic 8 because the loose underlying Lucene version that is used for data storage is compatible, but I can't take your indices to Elastic 9. For that to work, I would have to reindex everything. By reindex operation, what happens is we actually create a copy of an index with our desire. If we want, we can change the shards and everything in the reindex API. But what Elasticsearch will do is it will reingest every doc again with the newer Lucene version that would be compatible to be upgraded to 9. So in that way, there would be changes to the upgrades when we do related to indices. When we move from on-prem to cloud, if we are talking about the migration, if we are on the same version that we are migrating, we don't need to worry about how even there won't be any change in the indice mappings and everything. Everything will remain the same. If we want, we can do some settings to change the replicas or anything. That too, if our business requirements are in methods like snapshot and restore, it gives us flexibility to do so.
Okay, thank you, Rishabh. I think that's it for our questions. Rishabh, is there anything else that you'd like to address before we wrap it up?
Yep, I'm good. We can wrap it
Hey,
up.
Rishabh, can you guys hear me?
Yeah.
Yes, this is Rajshekar. So you answered the indexing when we are going with as is version, higher version. I understand that, but my second
Hmm.
part of the question, say assume that I'm the first time implementing or my cluster capacity is growing up and business is growing up, right? So I
Hmm.
just wanted to understand. See, I know because we implement a lot for our customers, but I wanted to hear because you are specializedly talking about this. How do you define how many shardings are required based on the say today is 45 TB or tomorrow something like that based on the data volumes and growth and replication factor whatnot, right? So can you little talk about how do you decide the number of shardings based on the hardware capacity what you have? Take one example and then if you can walk me through that will be great.
Sure, sure. So when we talk about shardings, we usually go to the index level. The best practice is to have this a single shard size to be maximum 50 to 80 GB for optimal elastic performance. So if I say my index is gonna be 100 GB or 200 GB, then I'll make sure that my primary shards are 4 because I want this shard size to be kept at 50 GB. And as a whole cluster, when we talk about the performance metrics, there is a simple rule that we follow. We say we'll have 20 shards per GB of heap in my cluster. Let's say if I have 100 GB of heap in my cluster, so maximum shards that I would allow in my cluster, so it performs well, is 2000, and that is combined, including all the system indices and the indices that I'm going to create. That is something that we do as a calculation basis. It would work even if we have 30 or 40 shards per GB of heap, but it is always recommended to keep it around 20 and for a single site shard size to be approximately 50 to 80 GBs for logs and metrics workloads. Does that answer your question?
Okay, thank you.
Thanks.
Thank you. Thank you, Rishabh. We are a little over time now. So if there are any questions from our audiences, please write to us at marketing@hyperflex.co. We will take up your questions there. Rishabh, anything before we wrap up from your end?
All good. See you guys in the next webinar when we do more hands-on.
Thank you, Rishabh, for this wonderful session and for our audiences who have joined us from a lot of different places, Ireland, Egypt, US, Chicago. Thank you to each one of you for joining us. We host webinars like these every month. So please follow us on our website, hyperflex.co, and our social media channels such as LinkedIn and YouTube, where we do post about our updates regarding webinars. We also put a lot of content, blogs, etc. So please follow us there. And yeah, please write to us at marketing@hyperflex.co if you have any further questions. Once again, thank you everyone for being here, and we will see all of you in the next one.